Okay, so I want to do a little bit of introduction before we get into our lab, which is review of the concepts we learned last class. First, an insulator, as we stated, are the materials where charges are not able to move through easily. So you've got glass, dry wood, most plastics, cloth, and dry air. This lab that we did this morning was really hard to see because in the morning there's a lot of moisture in the air. I'm hoping because today's supposed to be a hot day that we'll get a little bit better results in this class and maybe even better in fifth period because dry air is key to making this lab work. The conductors are the ones where electrons move much more easily. So we've got metals, plasma, water, graphite, and air. It means that electrons are able to travel through it. And if electrons are able to travel through it, that's how you generate electricity, which is why most of our wires are made out of metal, right? Because electricity is a transfer of electrons or charges. Now, at the molecular level, we've got insulators where the atom is going to hold on to those electrons pretty tightly. If we have conductors, we've got the atoms with something called an electron cloud where the electrons are free to move from atom to atom. And we drew a diagram of this in our last lab, right? You showed how the electrons can move away and close to the charged object. Now, when we get into our lab today, we're going to use our sticky tape lab. So I didn't keep my, my stands for you guys because we have to pass it along to the next teacher, but this works just as well. You can grab a meter stick. You're going to create a top and bottom tape once again, and you're going to set them on ends of the stick. I think because it's wood, it might keep the charge on the tape a little bit better versus some of my students used the table and they kept losing the charge on their tape. When you do this, you want to make sure that the tape is charged correctly. So you test it. You want to make sure the top and bottom, what should happen if you held the top and bottom together? They're going to attract. Oh, yes, you're right. They're going to attract, right? Because what happens when we have opposite charges? They attract. What happens if they're the same charge? They repel. Now, the thing is, when you do your experiment, you're going to create a charge in these objects. So you've got metal, you've got styrofoam. So the reason why we're using these different materials is important. Think about what you just learned about insulators and conductors. And you're going to create a charge through the triboelectric effect when you create charge through contact. The styrofoam itself needs to be pretty vigorously rubbed with a fork cloth to get a charge. You're going to know you have a charge if you end up with some sort of attraction. So this is pretty weakly charged, but there's a little bit of attraction, right? Now, in order to figure out what charge I have on my plate, you're going to hold it up against your top and bottom tape. So what charge is my top tape again? Positive. So the bottom must be negative. If my plate attracts the positive, what does that mean? It's negative. Is that the only possibility? Tape.
Neutral.
It could be neutral. So don't just test one piece of tape. Always go and test the other. Because if it also attracts the bottom tape, then we know it's neutral. If it repels it, then it's definitely negative, right? So, what I want you to do, this lab the effects are very small. So, you've got one metal pie pan with a tiny light bulb on it. The light bulb is connected by a wire. We know wires because they're made of metal. They're going to be conductors. And I'm going to have you first create a charge as best you can. I mean, really, I had students with sore arms by the end of the period because they kept rubbing their styrofoam plate. But you're going to do several steps of this lab where you're going to hold it just above the plate. We call this induction because I don't want you to have contact, but I want you to hold it close. And then as it's held close, you're going to have a partner touch the metal end of your light bulb. Now, I'm going to dim the lights because you should see a tiny flash. And there's two sides of the light bulb that you want to look at because that's going to tell you how the electrons are transferring. So in your packet, it tells you exactly how to know, but if the right side of your light bulb is lighting up, that means the electrons are coming from the right. If the left side is lighting up, it's coming from the left. You're going to do this multiple times. Hold it down, touch the end, hold it up, touch the end, over and over and over and over. The reason why I'm having you do it multiple times is because it's pretty fascinating to see what happens. I'm also going to have you tell me what charge is on the plate after you touch it near the styrofoam plate and after you touch it above the styrofoam plate, because something's going to happen. But you're not going to know it unless you actually test it with your top and bottom tape. And then after you see the effects through the light bulb, you're going to feel the effects without the light bulb. So if that light bulb lights up, that means electricity is being generated, right? And electricity is generated when what happens? I mentioned it many times. What's happening when we have electricity? Electrons are moving. That's grounding. When electrons move, you feel a shock. Now, you saw the electrons move through the light bulb. Now you're going to feel the electrons by feeling the shock. The shock is going to be really small. You might not be able to feel it, so you want to try to hear it. I'm going to have the lights dim. I want you to try to keep the volume low, but as you're testing it, I want you to make sure you get a really good charge on this plate. Again, you're going to notice a good charge if it starts to have some attraction. Obviously, when you pull it up and put it down, you're going to have to hold the pie plate down. But the stronger your charge is, the better you're going to feel and hear the effects of the shock when you hold it below and hold it above. So we're testing two things. We're testing induction, which is when the pie plate is not touching, and we're testing conduction when there's physical contact. What happens? Is there a transfer of electrons? What direction is the transfer of electrons? What charge are your objects after you've touched it? That's what these tapes are for.